Section 3, Video 3. Our first property of a triangle that we're going to look at is an altitude. I typed out the definition so you can more easily read my writing. So our definition of an altitude is a segment from a vertex to the opposite side. So they give us a couple examples here. They have one going from the vertex A to the opposite side and creating a right angle, and that's the key to be considered an altitude. Now that also means that I could draw another couple altitudes from the other vertices. I could go from angle C across the triangle. As long as it creates a right angle, it would be considered an altitude. And then again, I could also go from the third side, as long as it intersects it at the right angle. Now another example is where if I wanted to go from this vertex A to the other side, I couldn't make a right angle. Unless, of course, I extend that opposite side beyond its actual length and then draw the altitude down to make a right angle. This does not add actual length to that side, it just merely extends it so that we could draw an altitude and be given the information about how long that altitude is. So it's an adjustment of sorts so that you could draw an altitude, but it's going outside the triangle to get it done. And the third example here is we're given a right triangle and we're extending, or are going from that vertex, the right angle vertex, to the opposite side and creating a right angle there. Now this has special qualities which we will discuss at another time. Next, an angle bisector. Well, by definitions, we've had this before. It is something that bisects an angle, and the key to this is that it does create two equal angles, and that is shown by the tick marks. So keep that in mind when you're told you're given an angle bisector. A perpendicular bisector, well, again, by definition, we are bisecting something. Okay, and if you look at the picture, we are bisecting a segment. Okay, but we're not just bisecting the segment, we are creating a right angle when we do it, so therefore perpendicular comes into play. So a perpendicular bisector. But what you also see in the picture is something a little unusual, is this line seems to come from nowhere. It doesn't come from a vertex, and that is something that by definition a perpendicular bisector does not have to do. All it's telling you is that it is cutting a side of a triangle in half and creating a right angle at the same time. So our definition, our definition is it cuts a segment into two equal pieces, which we know, and it does not have to come from a vertex, which the picture shows, but it must be perpendicular to the side that it bisects. Now this piece here is a typo, so you can ignore that. Now we're going to go to the other page and move to midsegment, because that should be a part of this discussion. By definition, a midsegment is that it connects two midpoints of two sides of a triangle. Now in this picture, the midsegment then would be considered AB. Now if you look at the picture, it tells you by tick marks that these two are the exact same length, and these two are the exact same length. So we are indeed intersecting two midpoints, so the middle of each side, and it then can be called a midsegment. The properties of midsegments are that it's parallel to the side that it does not intersect. So we can add this notation and say that AB is parallel to XY, and that's a property you get when you know it's a midsegment. And also by length, it is half as long as the side that it does not intersect. So if I called AB an arbitrary length, just calling it length X, not knowing what it is, XY would be twice as big. And this ends section 3, video 3.